Hey everyone, welcome back to the Abom79 Podcast. I'm your host, Adam Booth.
And co-host Abby Booth.
What do we have to talk about today?
We have a long list.
Oh, we do? All right. Well,
This is another mixed format day.
mixed format. Well, I love mixed format. I like being able to just freely discuss whatever's on our mind.
I really enjoyed our music conversation. So I think I like to put in a little bit of personal information to each episode. So today, I think we should talk about your first job.
My first job?
Your first job. It's a place that I love.
You want me to talk about my first job? Okay.
Yes.
Well,
I wonder if most people could guess what it's going to be.
yeah, go ahead and start submitting your answers now. Just to be clear, we're gonna talk about my first job that I actually go and I clock in and I get a paycheck and that kind of
Yes,
stuff. Right?
not his first machining job, but although I don't even know if you remember your first machining job.
No, but when I was younger, I did a lot of mowing lawns and grass cutting and stuff in the neighborhood. I did that a lot growing up. I had several yards and I was making like $100 a week. $20 a pop for these yards, That was,
You were rolling in the cash.
yeah, I was using Dad's Snapper self-propelled mower.
Were you using it to buy CDs?
I don't remember. I don't remember what I just had my own money. I could go to the store and buy myself a drink and a snack. Anyway, my first real job was with Taco Bell.
I love Taco
The
Bell.
Taco Bell in Pace. I went to high school, Pace, Florida, and we had a Taco Bell there. I think in my generation, like so many people from Pace worked at that Taco Bell. It was like everybody just
like
had
a rite of passage.
Yeah, everybody worked at Taco Bell. But anyway, that was my first real job. I remember I was 15. We were getting ready to. I think my birthday was coming up in like 2 weeks. Because I don't know how it is now. At the time, you couldn't actually start a real job like that until you were 16 years old. Mom was up there and she asked the manager about is she hiring? And she said, "Yeah, I'm always looking for people." And she said, "My son's about to turn 16 and he's going to be looking for a job." And so she gave Mom an application to bring home. And so I filled it out, went up there and turned it in, and they hired me.
That's so cute.
So so I wasn't 16 yet whenever they hired me, but they said, as soon as you turn 16, you can start working. So they had me on the schedule the day that I turned 16 years old. And I worked at Taco Bell.
So you worked your birthday the first day.
Yeah.
That's adorable.
Yeah.
Of course you did.
My birthday is October the 8th. And that was my first real job. And I enjoyed it. And I was good at it. I was really good at it. And I think it was that first job is when I started seeing the signs of me being someone who is I just want to do my job and do the right thing as an employee, do the right thing, and working with people that didn't care the quality of work that they did or what their responsibilities were. I did work with people that did, but I also worked with people that just were there just to waste time and collect a paycheck.
Yeah.
But I enjoyed it. I worked that job it wasn't a year. I want to say it was getting close to summertime the next year. I had another opportunity to go work another job, so I ended up quitting Taco Bell and getting another job somewhere else. But that was my first job. I learned how to make tacos, make burritos. We were making chalupas, tostadas, Mexican pizzas.
100% of the time when I make a burrito, which I absolutely love, it's probably my favorite food of all time. He's over there in the background going, "You put too much in there.
She always overstuffs.
You overfilled it."
She overstuffs. No,
know.
you got I remember the spatula. You have like a burrito. You put some beans on a tortilla, and then you had this other spatula that was formed so that it would have the right amount of ground beef, and you would scoop up that and you'd put it on there. That was the perfect amount of ground beef, and then you go down the vegetables and the cheese and all that stuff, and you put it on there, and then fold it up.
Do you know that I still order the same thing that I ordered when I was like 12?
Yeah, I do.
I'm 2 bean burritos with no onions, add nacho cheese. It's the only way to do it, everyone. Try a bean burrito with the nacho cheese on it. You won't be sorry. It does make it more expensive, but it's worth it.
That is the only thing that Abby orders at Taco Bell is the bean burrito.
I'm sorry. I did go through a taco phase there. I mean, I think I've tried most things there, but it's the bean burrito for me.
So,
I could eat it every day.
So since we're talking about Taco Bell, my personal favorite menu item at Taco Bell, they took away and they finally brought it back with that new, what's it called?
The Decades menu?
Decades menu.
Yeah.
The 7-layer burrito. It has always been my favorite. I don't know what it is. It's a combination of the rice, the beans, the sour cream, the guacamole, the lettuce, tomatoes, and all that stuff. I love it. And so we got one, I don't know, a couple weeks ago. We were needing a quick meal, so we stopped by there. And Abby ordered me a 7-layer burrito since it was back on the menu.
He took a bite out of it and he went, "This is only a 6-layer."
Okay. Okay, let's back up a second. You remember how, like, the last episode, I told you about things that grind my gears?
Yes.
Well, let me tell you something else that grinds my gears.
Okay.
When you bite into a burrito, such as a 7-layer burrito, and it should have sour cream from one end of the burrito to the other.
Okay.
It should have guacamole from one end of the burrito to the other. So that every time you take a bite, it's all 7 layers, and it tastes the same. You shouldn't have one big blob of sour cream on one end of the burrito. And that's done because people are lazy.
If everyone thought like you, I think the world would be a much better place.
When I worked
Everybody
there,
would equally have exactly what they need.
when I worked there, you had these things that looked like caulking guns.
Yeah.
And it was a tube that had sour cream or guacamole, and you'd stick it in there, and so you squeezed it, and when you squeezed it, it just. And I would watch so many people. Those people that I told you didn't care about their job, they would pick up both of them like this, and go, just blob it on there. And I feel like that's what a lot of people still do.
Yeah.
And
I don't like watching people make
being
my
the guy
food.
that I cared about what I did and what I made, so I would take it and I would go all the way down the burrito with it, which is how you're supposed to do it.
Mm-hmm.
They actually taught you that's how you're supposed to do it.
You either probably love Taco Bell or you hate it, but
It's still one of the places you can go and actually get a meal for fairly inexpensive.
we had to X our local one though. That's kind of close to us.
They're just getting
No,
terrible, and honestly,
good.
it's getting terrible just about everywhere you go. Abby and I talk about it all the time.
Yeah.
You know, we go out to places like that because of a necessity, because we're hungry, we need a meal. You know, we're not at home, but the places are getting terrible. It's the service. It's not the food. It's the service. It's the way people treat you.
Yeah.
That's why, like the last episode we had mentioned, we started going to Chili's here recently, and we like it because, for one, the food is good, but even better than that, they actually treat you nice
they're
there.
nice.
They're
Yeah.
kind, they're exciting, they're glad you're there. They talk to you.
Yeah.
They compliment Abby on her earrings, you know. And then you go to the local Taco Bell, and it's just pandemonium
What do you
up
want?
there. Yeah, it's to me, it's what you want. You know, that's how they treat you. What do you want? And then you're sitting there for 20 minutes waiting on your taco, and it never shows up, you know, and it's like you have to go up there. And now all the places you have to order your own food, which is even more annoying, you know. It's like
He hates that.
the kiosk you have to go to, and they're standing right there, and they will not look at you. They won't point you. They won't look at you in the eyes because they know that you're wanting to
You're
act
gonna
like,
ask.
will you take my order? You know, and they're like, no, sir, you have to use the kiosk. And we see these like elderly people in there. They're getting annoyed and frustrated because they don't know how to use that machine.
I have helped many people at a kiosk.
I think it's, you know, these companies are looking for ways to cut expenses, but I just honestly feel that's something that just needs to stay.
Yeah.
You need to have people, pay them a salary or by the hour to stand there and take your order.
Yeah.
You know, I hate it. We actually have a new, what's the other taco place that Del Taco.
Del Taco.
We just got our first Del Taco. Well, this year we got it.
Yeah.
And we've gone over there a few times, and I actually like it. I like it better than Taco Bell. And they do the kiosk. So you walk in, there's 2 kiosks there. For one, they're too close together. So you're standing here trying to order, the next person's right there
Right
on your
there.
shoulder.
Yeah.
You know, come on, give us a little bit of space, a little bit of privacy here. The people are all back there taking the drive-through order, making the food, handing out food orders. They have 2 registers there.
Not making eye contact with
But
you.
they will not make eye contact, and they will not offer to take the order for you.
Yeah.
And we're all getting annoyed because it's like, it's confusing.
Yeah.
It's like, You have to learn how to use the software before you can just be efficient at it,
because
right?
I want to add nacho cheese to my burrito, everybody. So here I am scrolling, like trying to find it.
So companies need to leave somebody on the payroll or have people to take your order. That does not need to go away. That needs to stay. That needs to be a constant.
I think we saw something in New York where it was like a screen and it was a person.
I saw that on Instagram.
I'm kind of intrigued by that. So you actually get to talk to a person that's hopefully nice.
It's a different concept. So what it is, it's restaurants, and I don't even know what kind of restaurants. You walk in and there's a screen there of a person that's live. You're actually talking to a person.
So they're in their jammies.
They're at home, but
and
here's the thing. It was in a different country. I want to say it was the Philippines, maybe. Philippines. It was an Asian country that they're hiring these people to work, and they're paying them by the hour, but they're on a screen, but you're looking at them. So you're actually talking to somebody live.
A nice person.
You're talking to somebody, and they're taking your order, and there's another screen there that shows the order.
Yeah.
And instead of, I think it's also because people are having a hard time filling those positions.
Yeah.
You know? So they're like, okay, well, you got these other people that want a job and want to work. Let's just hire them.
Yeah.
And they don't even pay them the same rate, because now everybody wants $25 an hour to make you a taco and a hamburger.
That's a different subject.
Yeah, it is. So anyway, that's a great way to start off the podcast there. What else do we have to talk about
All
today?
right. So one of the things that I wanted to ask you is, what do you think is the most intimidating thing about manual machining and CNC machining? And I know your answers will be probably slightly different.
Yeah. Manual machining, the most intimidating thing, if I'm thinking back to a lot of this work I did, especially like when I was at Motion, probably making sure that you don't ruin an expensive piece of material by cutting it undersize. I made a lot of gearbox shafts when I was at Motion, and a lot of times, we would have to order these big pieces of 4140 shafting, and sometimes these things are, $2,000, $3,000. Some of them are probably more than that, because we had some pretty big size shafts, and I imagine even now it's even more expensive because prices have gone up. So when you're on the lathe and you're having to turn that shaft, and you have to hit it usually within a thousandths of an inch. I'm talking about the bearing fits. You have a very, very close tolerance that you have to hit on a bearing journal on a shaft. And there's a tolerance there. You usually have, maximum, minimum that you have to fall within. It's usually within about a thousandth of an inch. Sometimes it might be more than that. That's probably the most intimidating, because you're making your passes with the tool, and it's real easy to take 1/1000th more than what you want. And so it's that final pass, it's that finish pass that you start taking, and you're just hoping that it's not cutting undersized. A lot of times, if I could get away with it, what I would do on a lot of these shafts, these gearbox shafts, where a bearing journal was, and a lot of times it's a pretty wide tapered roller bearing that goes on there, you would have another little area just in front of that was turned down maybe 2/1000 smaller, so that the bearing would actually kind of slip on there and then go over the actual interference fit journal. It helps align the bearing as it goes on. If you had that, it made it so much easier, because you could start a cut and basically stop it and go ahead and mic it and see where it was at on your size. And if you're right on the size that you want, it's good to go. Turn the lathe back on, re-engage the clutch, and let it continue cutting. And you might be thinking, well, then you're leaving a mark on there. Yes, you will leave a mark on there because it's rubbing basically. But if you have that little area that you have to turn down anyway, you're going to eliminate that.
Yeah.
That was a technique that I did quite a bit to ensure that the shaft was going to be on the size. And I would always shoot for the maximum tolerance that you can hit, and then add no more than 1/1000th of an inch. I would try to keep it maybe about a 1/2 thou over that, because I would use my emery paper. A lot of people hate this, but I would have my emery paper there, 220 grit, whatever. And if you get it super close within a few tenths, you can usually take your emery paper and buff it just a little bit, and it knocks the high marks of the tool marks off. So it brings it down like a few tenths very quickly and easy, so that you can kind of land right on that maximum tolerance there. And of course, if it's bigger than that, you usually have to end up using your files and your emery to file and dress it down to get it to size. And that's where modern stuff is a lot more efficient with the CNCs, because you can get these sizes just dialed in within 2 or 3 tenths of repeatability. That's the other great thing, is that machine is going to repeat every time. If you're just making one shaft, it's different, but if you're making multiples. So I think on the manual side, probably hitting your journal size on a lathe on a big expensive piece of shafting is probably the most stress-inducing part of that job. There's many things that will, a lot of times you're worried about how a tool is going to react. Deep hole drilling, you're worried about the drill getting bound up in there because of all the chips packing and breaking and snapping off, But I generally haven't had any problems with that. But I think that was probably my biggest stress point of manual machining, trying to hit your journal size without cutting it undersize. Because if you did, you just ruined a very expensive piece of material. Now it just landed on your shoulders.
And you got to do it again.
Mm-hmm.
And not mess that one up.
Yeah, and you're letting your employer down, and you're costing them money at that point.
There's 10 more jobs behind it.
I was very fortunate that was a very minimal thing. I did not have very many mess ups. I can't even really think of any offhand that I messed up. So I had really, really great success rates with all the shafts that I turned. I know I made mistakes here and there, but I just can't think of very many that just stand out.
Yeah.
But to be fair, everyone there made a mistake here and there. Everybody made a mistake.
Yeah. People acting like they don't make mistakes is silly.
I just remembered one. We had a big hydraulic cylinder, and I was machining a new ductile iron rod gland for it. And so, you have to screw them in there and make sure the threads, everything fits together. I had one of those things, I was screwing it in there, and it started binding up, and it galled, and we could not get it to remove. No matter what we did, we could not unscrew that gland from that tube. At that point, those threads, you can't really see it until you get it all apart, but just one little tiny sliver of a piece of material is in there, and it starts rubbing those threads, and then as it's moving, it's just pulling more material and galling and building up to where it's an interference, and you cannot get that stuff apart. So I had one that I literally had to machine out of the tube. I just made it, but I couldn't get it to unscrew because it was too tight and it galled. I actually had to go in there with my boring bar and just bore the whole thing out just to remove it and then make another one.
Dang.
Yeah. I'm sure I'm not the only one that's had that problem, but that one will ruin your day right there.
Yeah.
You put all that work into that part for nothing.
Yeah. Well, I mean, it's never for nothing.
It's a learning experience.
That's right.
Every time you do something, every time you fail or make a mistake, you're supposed to learn from that.
I think that a lot of time it stops people from continuing. I hope it doesn't.
Yeah. No, you can't quit. You just got to keep going. But you want to do better. You want to use that. Like, for example, I was recently on the TRM lathe. I'm sorry. The TRM mill is what I meant to say. And I was setting up to do a little job. And when I put the tools in there to come out and do the part, I always slow the rapids down to make sure the tool, now I'm learning how to look at the screen and make sure to see our distance to go, and you can visually see that the cutter, okay, it looks like it's right on the top of that material, it should be right there. Well, it came down and it was like that far away from the workpiece and started doing its cutting, and I'm like, well, that's not right. All right, so I put the probe back in, the Renishaw, probed it again, started it again, still off. I probed it a third time, still off. I'm like, what is going on? What's the matter here? So I took my tools. I had 3 tools. I touched them on the Renishaw tool setter again just to make sure, because the batteries had went dead, and I had to replace the batteries in both the Renishaw probe and a Renishaw tool setter, 1 day apart. That's why you have spare batteries in your toolbox, and I did. So I was like, well, maybe it's the batteries, maybe it's, it needs to be recalibrated. So I talked to Steve Sherman at Miltronics. Or I sent him an email as like, man, I'm having this issue. When you have a moment, can you please call me? And he called me. So he started talking me through, he's trying to figure out what's going on. All right, well, let's do this. And he goes, all right, well, let's go ahead and let's put the probe back in there. So go ahead and do MDI, and we call it Tool 99. And when he said that, I'm like, oh, MDI, Tool 99, T99M6, install, run, cycle start, and that installs that tool and so the machine knows that that's the tool you're going to use to touch off. And it dawned on me right then, I forgot to do an MDI install the Tool 99. I installed the probe in there and just went over and touched off on my workpiece. So what the problem was that the machine set the G54 location using a different tool, the tool that it thought was still in the machine, which was a cutter, which was much shorter, which is why when the cutter came down, it was like 2 inches high because it thought it was here. So what I did is I totally forgot, and I don't even know why I forgot this because I've done it a lot of times now. I forgot to do an MDI and install the probe to set my work offset. And how I just one day just simply forgot that, I don't know. But that's the great thing about having Steve is, he called me and we walked through the problem and I told him, I was like, oh, I think I just figured out what was wrong, man. I forgot to do an MDI and install the actual probe before I set my work offset. So I told myself, well, there's another learning experience.
That's right.
So I'm trying to remember now, every time you go to use the probe, you have to install that Tool 99 before you do your work offset.
Well, you'll do it next time, won't you?
Hopefully I will.
Yeah.
And and so if it does happen again, hopefully I'll remember, okay, what's wrong? Maybe I forgot to install the tool probe, and so I need to do that and make sure you go to MDI, Tool 99, M6, run, cycle start, boom, the tool is in there now. Now you can install the probe and it should be good. So once I did that, everything was perfect. So I was like having a panicking moment. I'm like, what is going on with my machine? And that's when you're new like me, you sort of have this desperate moment of like, there's nobody around here that I can ask what to do. I have to figure this stuff out myself. And that's why I'm very thankful that I have people like Steve and people like Kevin on standby that I can email and call if I'm like really desperate, and I value people's time. So I don't just start calling and texting out of nowhere. I mean, sometimes I'll text, I'm like, hey, when you have a free moment, will you please call me? I need to ask you something. So that's something that I try to do. I try to respect everyone's time.
Yeah. So what is the most intimidating thing for CNC machines?
CNC.
Probably related.
Yeah. So my first thought was when you go to push the cycle start button and worrying that something is not right, like what I was just talking about with the work offset, worrying that something is not right and you're going to crash the cutter or crash the machine. And it has happened. Thankfully, nothing major. I've broken some end mills. I've broken a drill bit, a nice expensive Walther carbide drill.
You were so upset.
I forgot to, when I broke that drill, I forgot to set it on the tool setter. It was one of those things, I just forgot to do it. So I stuck it in there and I was so confident that it was going to work. I hit cycle start, I didn't slow it down. It just went boom. Boom, and it just shattered that drill into 1,000 pieces. I'm like, oh man. But I learned that I didn't set the tool. But it is very intimidating when you're ready to actually start the process of the cuts. And you hit cycle start and you're just worried that, it's going to come down, it's going to hit the workpiece, it's going to shatter the tool, it's going to do something wrong. So that, for me personally, that's the most intimidating thing about CNC. And the more that you do, the better you get at this and the more experience you have, that starts lightening up a little bit. And Kevin's tried to explain to me, he goes, I think you're starting to see that at first you're very nervous that this is not going to work. That even the fusion software that you're using is not going to work. It's not going to make the part that you're trying to make. That it's going to do something wrong, right? And he said, you're seeing now that it's not going to fail you. It's like I haven't had any problems with the software. The only problems I've had is when I did something wrong. I input something wrong, or failed to set a tool, or failed to use the probe properly, or failed to probe the workpiece in the right orientation that it should have been. So these are a lot of the basic things that you have to learn and know how to do properly in order for the CNC work to be done properly. But the machine is going to do exactly what you tell it to do. If you tell it to do something that you don't want it to do, it's going to do that, and it's going to mess your part up. But it's not the machine. The machine's not doing something out of the normal. It's you.
You want to be able to blame the machine, but
but it always comes back to you. Like, what did you do wrong? The machine just did exactly what you told it to do. It broke that cutter because it thought it had a little tiny drill in there, and you put this big giant drill in there, and it just slammed into the workpiece. So I don't know. I think it's hitting the cycle start button and worrying. Like, even with the drill indexes, when I was first getting going on them, every time I hit cycle start, I slowed it down, and I was that little tiny 1/16 end mill. I cannot believe that little end mill did not snap off. It did all those drill indexes, and it's still cutting. It's still within 1/10,000th of an inch every time it comes down, and it works. So what Kevin was saying was, now that you see that it works, you start having a lot more confidence in it. You feel a lot more confident about hitting the cycle start button, and then you're standing there and you're drinking your coffee and you watch the tool come down. It doesn't crash. It just starts doing exactly what you're telling it to do.
Yeah, I remember when we went to lunch on really one of the first days that he left the machine to work over the lunch hour.
Yeah.
And he had the camera up at the table, sitting there staring at the machine. Just, is the light on? Okay, everything's fine still. The red light's not on, right? Okay. So it's amazing that it just does its thing. I have our security cameras where I can pull it up on the phone, and as Abby said, we were at lunch, and of course I'm nervous because it's like I'm sitting there thinking, like, even if something breaks, it's going to continue to keep cutting. So that's that's something that we'll have to learn about. I know some of the other machines have things built into it so that if a cutter does break, it basically stops and alerts you or whatever. Our machine, if the end mill breaks off, it's still going to go through the motions there. So my hopes was that we didn't come into an absolute mess. Yeah,
but
and we didn't.
We didn't.
No.
And I start with the first couple batches of drill indexes. I was getting used to loading them up, hitting cycle start. I knew about how long. A lot of times what I did is I started a timer on my phone so that I would know how long it was going to be before the cycle was was ending. And so I'd load it up and I'd go and work on something else. That's a great thing about CNC. You load up the machine, you let it be making these parts, and then you go over to the manual lathe and you have a little bit of fun. You make this little part, that you got to make. You use all your machines all at the same time. The CNCs are back there making your parts for you, and you don't have to stand there and crank a handle back and forth. Yeah, but I liked what you brought up there. It's like we were at lunch and I was sitting there. I had my phone and I'm sitting there looking at it. You can see the green light on the top, so everything's going, and then you could see the machine moving around a little bit. It's not the best view, but you can see it in there, and it worked out great. And we'd come back from lunch, and the orange light would be on. The machine wasn't running. I'd go open the doors. There's 2 parts finished right there. And that's why I was wanting to get set up where we could do 4 work pieces. I wanted to kind of graduate to 4 work pieces, and if we get that figured out, maybe improve upon that. Maybe we have more in there. Maybe we have 6 or 8 work pieces in there.
So exciting.
Because I want to be able to get to that point where, like, a lot of people consider it lights out machining, where your machines are running around the clock. Yeah. That's where the automation comes into. But at the minimum, and this is what we did, was whenever we would end the day. It's time to go home. I would wait until the cycle was done. I'd reset the machine with more work, and I would hit cycle start, and I would leave. I'd turn the lights off, and I had the Miltronics set up. I can't remember the code. I want to say it's M31. I can't remember which one it is. See, I'm not good with the G codes. I'm still trying to remember a lot of them. But basically what it did was at the end of the cycle, it turns the machine off into like an idle mode, to where the way pump is not pumping oil. The machine is on, the fan on the back is still running, the lights are still on, but the machine is it's basically e-stop. It puts it into an e-stop mode, so that when I come in the morning, it's just there waiting on me. I reset it, put more material in, and just keep going.
So awesome.
Yeah.
Well, let's talk a little bit about the fourth axis.
Okay.
Because that's coming.
Yeah.
You've been trying to get that up and going.
Yeah.
So talk about that a little bit.
The fourth axis is something new to me as well. Like all the CNC stuff, it's going to be a new type of setup that I want to learn, that I want to be able to utilize with our work. And I'm working on the tool holding right now. So we made our subplate. We've got that on YouTube. You know, we machined a really nice, accurate subplate that bolts to the bottom of the fourth axis, that allows me to set it onto the fixture table in the machine and bolt it down nice and easy. We got that taken care of. Now we got to work on the work holding, the vices or whatever fixtures we're going to use to hold the actual work. So I again had some conversations with the guys at Tico Manufacturing, Tico Work Holding, and we're going to be going with their 0-point system for the fourth axis. So their Raptor line, their Raptor Work Holding, we're going to go with one of their 5-axis style vices. We're going to have a dovetail fixture, and we're also going to go with a 3-jaw chuck as well. And this is, like I said, this is all stuff that I'm learning about. I saw the 0-point fixturing when we were at the IMTS a few years ago, and that's the first time I saw it. I know that it's really big in CNC now, but now we're finally getting to that point where we're learning about it. And it's really nice because it has these 4 studs on whatever fixture that you're using that goes into another fixture plate, the 0-point plate. You have one bolt that you tighten up, and it's there. And it's like, I think it's supposed to be within a 1/10 or 2 accuracy. Every time you stick it in there, it's going to be in the same exact spot every single time. So what they recommended is that we get one of their 0-point plates that is going to bolt to the face plate of the fourth axis. That'll be bolted on there, and it comes with some kind of gauge ring that bolts on there too, and we'll have to use that to get that centered up like you would center up in a 4-jaw chuck on a lathe. So we have to get that centered up really well, get it tightened up, and then once that's done, that's on there. And then we're going to have a vise, we're going to have a dovetail fixture, and we're going to have a 3-jaw chuck. Whichever one that we want to use for whatever type of job, we can simply stick that on the 0-point plate, tighten up the one bolt, and it's there. Now you still have to find the center of your work and stuff like that, but the work holding will be attached to the fourth axis at that point. So it's going to give us a lot of capabilities there. The vise will be able to, clamp flat pieces of material like you would in any kind of milling vise. It's self-centering, it's one of those style vices. The dovetail fixture is also something new to me, but I remember seeing that at the Mighty Bite booth at IMTS. And the guy there, I don't remember what his name was, but he was really cool. He was showing how all this stuff works. It's a really interesting concept. You take a piece of material, so it does require a first op in another vise or something, and you have these dovetail cutters, and you have a program that basically just machines this dovetail on the bottom of your workpiece. Very simple operation. It's a dovetail. Well, then you take that workpiece and you go into your dovetail fixture, and you tighten down the 2 bolts, and it grabs onto this dovetail, and that's how it holds it. And now you can essentially machine every bit of those 4 sides on the fourth axis there. that's going to be pretty cool to learn how to do that.
Very cool.
Yeah. And then, of course, we're going to have our 3-jaw chuck, too. We're going to go with like a TMX 3-jaw chuck, and it'll have a plate bolted to it that's going to have the 4 0-point studs that will go on there and, be able to use. So if we have a job where we want to put a piece of round stock in there, we can just use the 3-jaw chuck.
You cannot wait to get your jobs in there.
Yeah, I'm excited.
Yeah.
I'm excited. There's a project that I've been wanting to get to, and it's taken longer than I hoped, and I don't know if it's going to lead to where they may just have to take care of it another way or something. But I had somebody reach out. They need this stub shaft machine that's got a 3-start thread on it, but it's not your traditional V thread. It's a flat thread. It's not even a square thread. It's more of like 3 shallow grooves that have a super coarse thread lead machined on them that is for a very fast motion. And they asked me if I would make that for them, and I told them I would, but I said, if you're not in a hurry, I'd love to try that on the 4th axis. And they said, yeah, it's no hurry, take your time. And they haven't said anything about it, so I'm hoping that we can get it set up soon, and pretty soon use that as a really good training project and see how the 4th axis and the VM mill does, machining a 3-start thread, but not your traditional V thread, a flat bottom, shallow groove on a piece of round stock. So that's going to be a really cool project. I'm really excited to be able to get to that and share more about what that project is for. I don't want to reveal it right now, but it is going to be a fun collaboration, should I say.
I love that.
Yeah.
Well, we had a Tool Tuesday, and I'm not sure when this is going to come out in accordance to that, but you worked on adding your new coolant nozzles, and you were so excited about that. So talk about that a little.
The coolant nozzles, we just had as Abby said, we had a video, so you guys can check this out. On the CNC lathe, one of the things that I learned about, when we had the ML16, I always had issues with the coolant, really not being efficient, spraying over to the tool the way it should have been. And I should have messed with it then, and I never really did. I was like, I'm going to get to that another day, and I just never did. Well, when our SL8 showed up and we're getting it set up, ready to go, and I had Steve there, and I was telling him, I'm like, I need to find some of those nozzles that I can screw into the little nozzle ports here and try to get this coolant working more efficiently, which I will admit is a standard thing that everybody that runs a CNC lathe has to do, right? It comes with the ports, the little ball swivel things that blows the coolant out, but that doesn't mean that it's necessarily very efficient. It's not getting the coolant exactly where it needs to go. So when Steve was there, he says, well, there's this company I've always used. I think it's called RVing products, and they make the little, the lollipops, they call them, and they got some other stuff too. And so he pulled it up on the website and showed it to me. And we measured the one for my machine. The ball is 15 millimeters, and we looked at their lollipop extenders, and they make them in 15 millimeter. I'm like, that's perfect. So the lollipops, what they are is they're about 6 inches long. It's a copper tube, 1/8 diameter copper tube, and silver soldered to a 15 millimeter ball. And they make this to fit many, many different machines. So there's all kind of sizes. You just buy whatever size you need. And the way those are intended to be used is that you bend the copper tube around however you need to, so that you can deflect, you can bring the coolant directly to the tip of the tool, right? And I finally got to do that. I should have done that on the ML so long ago, and I just never did. And I finally did it because I told you, I said, I'm going to buy some of these nozzles, I want some of these tips, and get this machine set up the way it really needs to be set up. So I enjoyed that. We bought some of the lollipops. We bought some of the extender nozzles too, because on the tooling that's in line with the Z-axis, like if you're using a drill, you've got these nice copper tubes that you can screw into the nozzle and bring it out further. So if you got to go around like a collet nut or something, and you can put a bend in it like a 45 so that it's blowing directly onto the tip of the drill there. And I know that people are going to say, well, you can get through tool coolant on there. Yes, you can, but there's going to be cases where that's not always the fact. we have a lot of jobber drills that we use, and there's going to be plenty of times where I want that coolant blowing at the end of a high-speed steel jobber drill. So that's a really nice upgrade. I did our first set of tools. Some of the tools, I bought these little brass tubes that have the thread. It's an M5 thread, and you can screw that into the factory nozzle, and it gets it a lot closer to the actual tool, and you can aim it so that it blows right on the insert. So this is all stuff that you can make yourself. I'm fully aware, we have a machine shop. You can make these things if you want to. A lot of guys do. But it was one of those jobs where I didn't want another project where I have to, machine all these little pieces to go in there. This is stuff that's already been figured out. It's already been engineered. It's a professional product. So we just went ahead and invested and bought a few of them so that we'd have a few to go with. But it is certainly things that you can make yourself and just improve it yourself.
It did take some time to get that done.
Oh, yeah.
But now that it's done,
yeah,
it's done.
Yeah. Well,
you're going to have to adjust things, obviously, as you move on, but...
Yeah, and then like some of the guys left comments said, get ready to have a drawer full of those things. And I totally get it, because every time you stick a different drill in there, you're probably going to need a different nozzle. And that's why, you buy a pack. I think they come in packs of 5. You just get you a couple packs, put them in the drawer.
Yeah.
So that when we go ahead and add another drill, I can put those extensions in there, get them modified for that particular tool. But those lollipops are great because you basically instead of spraying it at an angle on one side, you bend the copper so that it comes around and you line it up in line with the insert like a parting tool, and you get it aimed so that it's blowing right on the tip of that insert. It's how you should be doing things with a CNC lathe. I'm just happy that we finally got there.
Yeah.
And got that modified. So I'm going to be continuing to improve those and modify them as we need when we're setting up different tools in the CNC lathe. Yeah. But that was Rovi Products. You can go to their website and they have all kind of, not just CNC coolant nozzles. They have parts, all kind of stuff for CNC machines too.
Well, I want you to get something a little bit different for the mill, the manual, because that one, when we were trying to
the mister?
I had to do it every time.
The mister?
It just seems like that should be a more efficient.
I think it just needs to be taken apart and cleaned.
Okay.
I think, and I'm so lazy about that.
That's what your shop assistant should do.
Well,
shouldn't they?
We can do it together so that we can,
great.
It's one of those things. It needs to all be taken apart.
Yeah.
Clean it, degrease it, use some CRC, get it nice and clean, put it back together. It'll probably be fine.
Yeah.
But when you're doing the job, you don't want to stop and do that. You're like, well, I'll just do that when I'm done with the job.
Yeah.
We're done with the job. We never do it. So it sits there and it gets gummed up.
Yeah.
So the next job, you're frustrated because the nozzle.
Yeah.
She's talking about the Noga Mini Cool, and the nozzle tip. You have to adjust it to get the spray pattern that you want, and it's like it gets all gummed up in there, so it sprays, and then it slowly gets to where it doesn't spray anything.
Yeah.
And then you touch it again, and it just blows like a water hose. So it doesn't stay. It doesn't stay the same all the time.
Yeah.
We'll get to that. We definitely need to fix that for sure.
It's amazing how much time those little things take up in the shop.
Yeah.
It's
little tasks that just take a lot of time. Yeah.
Yeah.
I think that's about it on our hit list for today.
That's everything I had on my list.
Yeah. We as we go through day to day our work, Abby just makes notes of things that we've been into and what we've been up to around the shop, and that's the kind of stuff we enjoy discussing on the podcast. So I think we're going to go ahead and call this one done, and we'll talk to you guys some more about some more fun things on the next episode.
That's exactly right.
So a quick mention that we're getting very close to having our Abom79 drill indexes ready to sell. We're almost there.
I think by the time they hear this, it's going to be
hopefully.
time. Yeah.
Hopefully. We're trying to wrap up a couple final details for them. They're going to be coming very soon. I'm actually really excited to get back on the production of them as well.
And I'm getting ready to start something that I think they're going to be very excited about.
Are you going to talk about that in the next episode?
I might.
Okay.
I might.
All right.
I'm excited.
I can tell. All right, guys, we'll wrap this up. We hope you enjoyed the episode, and we hope you come back for the next one. All right, we'll see you then.